Oh, yeah. So at the previous lesson, we learned basics of GUI, and we didn't start even with user inputs, right? Because it was one button and replacing of images, replacing a number on the screen, but it wasn't like user input of radio buttons or checkboxes or anything like that, right? So today we have 3 topics. Hopefully we'll cover to some degree all of them. One of the topics is how to move state variables outside of function where you place them. And it does make a lot of sense in user inputs and in organization of the code. We will use it a lot, so it is essential. Also, at the previous lesson, we learned that when we rotate the screen, data disappears. It is a fact that our GUI is inside of activity, and system discards activity when rotates the screen. It was originally designed in such way, and it just stays. So it rebuilds GUI, rebuilds entire idea. What is inside, I don't know. But it recreates the object. So whatever you put inside this object is discarded with the object. It's of activities object. So it's one way to, so we need to preserve data, and not only data, because preserving data is one issue. We also need to preserve processes that, or tasks that we start. So if we start task in your program, and it is directly linked to function or someplace in activity. So when activity is discarded, system will kill the task. And it is not a good idea, for example, if your program is getting data or sending data at this moment, so it will kill the task of sending and receiving data. So we need to do a lot better in terms of managing this discarding and recreating stuff of activity. Even if some data can be preserved with savable, as we saw before, remember savable, during rotation, this idea cannot be applied for tasks, because you cannot make running task savable. It will apply only to piece of data. Also, in order to make objects savable, you need to add extra code, so you need to modify every object, essentially, that you want to save. There is an additional issue to this. It is code organization. Typically, we need to separate business logic from GUI logic. We need to organize code in layers to make it easier to edit, easier to compile. We can have a module per layer. If it is a large program, it makes sense. Not in medium-sized programs. So we need to have a reasonable organization of the code. Plus, some building things when you start up shouldn't be discarded when you rotate the screen. Because, for example, you open database on hard drive of Android app, connect to the database. You don't want to redo the thing each time when screen rotates or something happens to activity. So there is a recommendation. So the best way to deal with it is to create view model. A view model is a special object that will survive rotation. And view models are maintained by the system as activities, similar to activities. But you need to ask for it. So there are some objects are created by the system. You don't call constructor to create them. For example, activities and view models. It creates, especially for view models, it makes additional issues when you ask system to create the object, and you need to provide some parameters to this object to be created. How would you pass the parameters? So this is always issue. It's not just a view model issue. It is issue for other objects that system creates. So you don't call constructor yourself. And even if you call, but you rely on the system of recreating this object after you call constructor, you need to provide some data to this object that will be used to create it. So this is one thing to be aware of. It is typical issue for Android and likely in other systems that when system creates object, you need to give some data to it, and it should be some way of communication to provide the data. And in some situations, you do call constructor, for example, when you create fragments. And after this, you use data, but in the rotation, a system will discard activity, and what is fragment? It's part of the screen, essentially. Will discard activity in fragment as well and recreate it. So at the time of the recreation, it needs to know how to build it. So it will call constructor, but where to get the parameters. So so there are tricks to deal with it. And in constructor, in fragment, it's a part of the screen, similar to activity. There are layouts, there is a layout, there is some code associated with layout, and so on. So today we will deal with, today we will discuss it and deal with the first level, how to do it, okay? So the best place to find information about Android design, it is Android application design, it is Guide to Application Architecture. It is at developerandroid.com. Developerandroid.com and search architecture guide. Guide to APP architecture. So address is /topic/architecture. I will create the link to slide. So it starts with things that I already mentioned. Typical Android app contains multiple APP components. Activities, for example, fragments. What else? Services. What is service? It's also a special object for background task. It can run without activity. If you start task from view model, it does require activity at least to start it and pick up, but service can be launched when you boot your device. So in this case, you don't deal with GUI at all. Services, I use it to, for example, to check for emails, right? Or something like that. When application is not running, but it can, in terms of GUI, but it can still pop up you notifications, for example. So it's typical, or doing some backups or uploads, whatever. So this is services for background tasks, and they do not require GUI, and they are a separate unit of your app. Of course, when you create service and you have GUI, you need to set up communication in between. So when you launch GUI, it will launch activity, right? First activity, but you can add more, and another unit of Android system, it's called intent. Intent is designed to communicate between your app and framework of Android. And intent, this is actually meaning of intent. Its word is actually means that it's your intent to tell the it's your intent what you're going to do. You essentially tell the system of what you want. So there are, it's an object. There are two intents that contain code, which is constant, defined in the system, that describes what you want. For example, there is a code, open browser. There are dial phone number, dial phone, and there is another code. And it's also part of intent, to tell what you want. Also, there are intents, open specific activity, open specific service that exist. So as we see, there are explicit intent and implicit intent. Explicit intent tells the system what you exactly want, like open specific app, like activity specific app, or start specific service. And this is, call it explicit intent. And implicit intent, it's intent that tells the system dial phone number, for example. And it could be multiple apps in the system to dial phone number or open given URL, and it could be several browsers installed. So when your app communicates with implicit intent, Android can pop up message to user which of the apps to use. And if user previously replied, use this always, of course it won't come up again. So this is a feature of intents. Intent can carry data, obviously, when you open something you can. And there are two kinds of data, URI, for example, address on the web, and key value pairs. So intent can carry also key value pairs to pass. It's called extras, to pass the additional information. What are content providers? Content providers is specific also unit of your app to communicate to other apps on Android system. And it is not just as simple as intent. It is designed for data, for giving data to another app, so another app can send queries for the data. So it has similar interface to some SQL databases, for example, SQLite. It doesn't have to use SQLite inside to store data, but it has similar interface. It's not actual SQL, but it is API calls. But it is somewhat similar idea to SQLite in older Android when we had to call SQLite directly. So it is quite fun. Potentially, it is quite fancy. Why do we need special channel like content providers to communicate between apps? The reason is that every app is, for security reason, is running a separate user on Linux. Android, it's a Linux. So, and Linux has protections. So one user cannot read data of another user unless it is somehow permitted. For this reason, there is no global database on Android. Databases of Android, they are files inside of folder of that app. So it is and interface to this file is SQL based. So if Android is using SQLite under the hood to store structured data. Just because this data is not running as any kind of global service, it is just a app it's just a file in a folder of an app, and app is a user. You cannot read, for security reason, you cannot read data of another user on Linux system. So in order to make it available to another app, for example, address book, good example, right? Address book, one app, it can provide data to another app, right? Address book or calendar app, right? Because you know that apps can communicate to calendar, right? Or the same. It is implemented using content providers. Content provider, it's an application that is giving access to data to other apps. Content provider. It is part of the app that giving access to. And it is also unit, or independent, kind of partially independent unit of an app. So in order to read, say, address book data, you don't have to have address book app open it on the screen, right? So it doesn't have to run GUI. So it's bottom line, Android app consists of multiple units, such as activities, services, content providers, and more, that can run separately from GUI. And what do they tell? System is creating this object and discarding those objects. This is a key point. So we need to provide some means of storing the data. So when system is discarding this object, it's having this in the local database, or somehow it survives. So we need to provide some means of storing the data independently from these units. Okay, this is what they say. It is typical issue with Android applications. What are main designs? Separation of concern. It's the main design, say, principle in all software. If you have something specific for specific topic, specific use, right? Okay, one unit should be doing only one thing, essentially, separation of concern. Right? In particular, if we have activity, it should be used mostly for GUI, not for data saving or data reading. Okay. They mentioned fragment. In this course, we will not deal with fragments directly, although we will create some project just to see what they look like. Because fragments are a way to deal with pages and parts of the screen with older GUI. And it takes time to learn how to deal with it, and they are not super useful in new GUI. In fact, the textbooks that use composable functions for user interface, and this is what we use, do not really explain how to use them. The course that I'm mentioning, Introduction to this Android Development with Compose, does have mentioning fragments in the end to tell how to combine older GUI and new GUI. But it's, there is a learning curve, how to deal with it, and it's not even close how to deal with compose functions. Fragments appeared since later versions of Android 3 and starting Android 4. So derive UI from data models. It means we need to create data objects stored in some kind of persistent database or on web, or a beta on web and have a local copy of it. Do not store this data in your UI, essentially. Have single source of truth. It means the data should be should be updatable only in one place. That owns it. Other places are allowed to duplicate it, but not update. This way, we will not get into inconsistent data. And its data is propagated from bottom up, like from database to the screen. And in order to update item on the screen, you do not update separately screen and database. You update database and it propagates up. So it is reactive, essentially. And you will see it even in simple apps, how it behaves. And what I mentioned, unidirectional data flow. Data is traveling from single source of truth up as duplication, yes?
Was that also like like if you make a mistake, you can go back because you have multiple layers that doesn't update together? Or?
It's not about programming, it's about how program runs. It's not mistake at the, what do you mean mistake?
So like, for example, like you said you have two, you duplicate but you don't update, right? That's what you said? So like, you do that because if something went wrong with the duplicate one, you can always go back to the one before it, or is it just so?
It is duplicated automatically. This is why it's not an issue. Duplication is automatic. It propagates through in your code from single source of truth to other places. And it propagates as not editable objects, immutable objects. So you have only one copy of editable data. This way you will not have inconsistent data. So this is, and events are traveling down. It means like if you click, you have user enter something, and it will create event in composable in UI. It will will not be like real event. It will be just function call, Lambda function call, and you will have chain of Lambda function calls, and eventually you will get update of database, and data data will propagate up. So, recommended APP architecture, and today we will deal with this and some of domain, but not much. What they say optional, they mean not the domain object that we created. This is technically not optional because you have to create data classes that carry data. What they say about domain layer optional is use case functions. It is objects devoted to specific functionality, and they are not data layer functionality. So it's like a separation, additional separation between UI layer and data layer. Objects for specific functionality. And separation is vertical. It is separation horizontally between UI and data layer. And there is also separation vertical for specific tasks. So the main idea about use cases in domain layer to separate tasks in horizontal direction. What kind of task could be? Like retrieve email, one email. It will be one use case. And another use case, list emails. Okay. So logically, it is separate tasks, and it can be done by different people, maintained by different people, and eventually in UI layer, it will be different compose functions or even different screens, right, in navigation, depending on design, user interface design. So it is the domain layer also exists like use case functions. Use case function, it's not a function, it's an object, but object containing one function. Use it like for specific purpose. And other functions could be called, but one, it is for actual name of use case, call that function. And why does it say optional? And one of the reasons why it say optional is that it doesn't always necessary. Okay. In most examples that in our course that we start in Google course that we use, they don't have it. I will create some just to show what it looks like, but they don't have it. And data layer is any kind of databases or network communication, creating local copy and so on. What we're interested in today is this. UI layer, technically, it's two pieces. It's not one. What we saw last time is UI elements, and we stored state directly inside of UI elements. Better design that we'll talk about today is using state holder. And state holders in Android, they are view models. Special object to store state. State of UI. There are two kinds of state. State of UI and technically state of app. Okay. State of app, it says somewhere like in data layer, it's some data that is not displayed, like email which is not on the screen, for example. It will be in database and it will be in data layer. But state of UI, it is what is related to what information related to what is displayed on the screen, directly related to what is displayed on the screen. So state could be here, but this is state of UI. Or also state of UI in terms of something is checked, not checked, this kind of thing. And if this data is preserved, it will be also mirrored here, down the chain. Either into database or in, depending on what it is, or in user preferences. User preferences are also on hard drive, and it is different storage. It's not database. It is data storage, but not database. Data layer consists of repositories and data sources. It is for code organization. We will talk about it when we reach this point. Domain layer is optional. It is already discussed. And what we want is architecture recommendations. What does it say? Okay, best practices. It just says something recommended, something optional, and strongly recommend. There are several recommendations. Unfortunately, what they say recommended, it's not always in examples of the course that I'm referring to. And this is why I'm adding this for you. Okay? Because what this guide recommends, it's not always in their course, but you better learn it. Because this is the last course that is using native Android programming. Okay. Strongly recommend unidirectional data flow. Otherwise, it's really hard to make it consistent. It's really hard to make it work without it. This is the reason. Strongly recommended use view models. It's coming today. To handle business logic, view model best practices here. It's separate link. Okay. Strongly recommended. This is how to link view model to view model data into UI. Do not send events from view model to UI. Because this will be opposite to unidirectional data flow. Because events go from UI to view model, not back. The reason why, because UI may be discarded and you try to call code on object that doesn't exist, it is potential crash. This is why. A view model potentially lives longer than UI. This is the reason. It is recommended. Use single activity application. As previously discussed, all the way is to have multiple activities inside of the same app. It creates additional complexities. In terms of navigation, how to change screen, because this way you can share data only through external data, through database or key value pairs, which is a really bad way to wrap the data. So it is single activity. We may encounter two activities if we open another app, obviously. There's no other choice. Recommended use Jetpack Compose. Use either compose navigation or navigation for fragments. Fragments is all the way, and potentially they tell it is somewhat linked, but it is a lot more complicated to do. So we will use navigation compose. So we're good, and also the course is using it. A view model. Okay. So essentially, they say view model should be agnostic to Android lifecycle. Android lifecycle, it's creating and destroying objects on the screen, for example, activity. So it should not be linked to existing objects like an activity, fragment, and context for the reason that these objects do not necessarily exist and they can be replaced. Because it is destroying, a system is destroying this object and creating them again. So if we create some kind of reference to this object inside of viewModel, this reference will not necessarily stay valid. It may be a reference to the object that is discarded already, or about to be discarded, or discarded by the system, but since you hold the reference, your system cannot garbage collect it. Because you're familiar with the concept of garbage collection, right? When you do not use an object, but you hold reference to it, a system cannot pick it and reuse the memory. So this is the issue if system discard activity, but we still have reference to it in some variable, it will be discarded from the screen, but it will stay as a garbage which is not collected. So this is what they mean. If you store reference in somewhere outside of the GUI to a GUI, it will be referenced to something which is not on the screen or even don't even exist, depending on the situation. Okay. There are other things, including this is you will see when we reach this point. It's how to stop and start tasks. Use viewModel, not Android viewModel. And we will stick to viewModel because it is how all examples work currently. Android viewModel has a reference to context inside of it. Context is the object that, context of application. What is context? Context is an object that has basic information about the app. And context is a base class for activities, processes, and other things, not fragments. It is just base object for major units of the app. And it is used to retrieve information, for example, folder where you store files. This kind of basic information. And a viewModel doesn't have a reference to it, and we don't need it technically. Android viewModel does have a reference to context, and it appears like this creates inefficiency for the system, so now they don't recommend it anymore. In older GUI, it was quite convenient to open to initialize database, because initializing database requires location of the hard drive, and since Android viewModel has reference to context that has information where it is, it was a sensible way to do it. Now there are better ways of doing it, so they don't recommend it anymore. I recommend you should make UI state a state flow. This is what we will not do it today because it is more complicated, but we will do it next week. Okay. UI state a state flow. And use state in to convert flow into state flow. It is a technical issue, and there is no other reasonable way to do it. We will just stick to it. It is what happens in viewModels. Handle dependencies. Use dependency injection, strongly recommended. Scope when necessary, I recommend use it here. Okay, this is the part that Google course that we use is not doing. They do use dependency injection manually. It's a little somewhat tedious for small app, but easy to do. But for larger apps, it becomes a chore when we need to link lots of objects. A hilt is the system that is creating and linking objects of your app. If we have an object that has mutual dependencies, it takes some skills to create them and link them right way in the beginning. It can be done manually, and they call it like manual dependency injection. And most of the examples do this way. I also, if I use the example, I have two versions sometimes, their version and my version, that is using hilt. So this is drastic difference between their course and what we have. We'll have either hilt or both. In the beginning, we have both to compare, and later I will just use hilt. In my own examples, I will use hilt. I don't do it two ways, except one example that is done two ways. Testing, you're already familiar with that. Models, I'm scrolling to UI layer. Okay. Sorry. I'm missing extremely important piece, and I don't see where it is. Okay, just, no, not that one. Here it is. This is what, this one. UI layer architecture. UI is composed of two UI elements in UI state. UI state is better to be in state holders like view model. And here is how the mechanic happens with view model. We have UI elements, for example, that has a button, for example. We click on the button, and it creates event. Event in UI system, it is just call of a Lambda function. So eventually you have a call of your model from the Lambda function that you created. And this call update UI state. Either directly like here, store it in view model. Or it goes to data layer and eventually reach update to UI state. And UI state is reflected in UI system by meaning of triggering screen update. So it is always, if I use view model, it's always communication going this way. So there is no direct screen update inside of GUI elements, unless you put date state holder here, a state here. It is always updating data in view model if it doesn't go to database, and updating state will trigger update of the screen. If we have data layer, it's more interesting. Event is calling function in view model is calling function from data layer. Update happens, and then a data layer also reactive. So it will cause some code in execution of some code in view model, and it will trigger update of the screen. Okay. So events are propagating this way, and data propagating this way. So this is our unidirectional data flow, what they talked about. Okay. So this is the idea about view models, how they communicate to data layer. But today, we will have all data here. We will not send it to data layer. Okay? It's extra step of complexity, but we will deal with data soon. Data layer soon. And this is what I wanted to talk about it up to this point from theoretical point of view. So what is next? Oh, should we have break, or probably no? Let's have short break. Okay, let's have short break. I will stop recording. So either open dice game or clone it. Cloning is not long. Start recording. And how to clone it? click on it, a code, copy, then I'll open Android Studio. I'll clone repository, find the place where you want it to go, Command V. When you clone, make sure that it is creating a folder for it. And after this, click clone. If it's not creating folder, you need to type or copy paste it. It's not always consistent. And you clone. Trust project. When this opens, it's typically when it is cloned project, sometimes it opens, just close it. It will fix it itself. So I'm cloning this game right now. If you did it at the previous lesson, it is the same, so you don't need to. I use a different laptop, this is why I'm cloning it. Now it is building it. It is multiple cube application, example with multiple cubes. It does have user input in it, number of days. And this makes it really different. Okay. It seems like it did clone. At the previous lesson, we briefly browsed code of MC project. We added some code to another project. And we also briefly browsed this one. And we learned there is some data generation class to generate data. It is different from dice cube. In dice cube, it is just one dice object generated one number. In this case, it is different code that is generating object type raw data. What is object of type raw data? In the domain, I define it as a class. Remember that when we say val in front of val or var in front of parameter of constructor, so this is constructor, this is parameter of constructor. It is shortcut to create instance variable inside and assign that value to it. So this is why values are not declared here in the class. Because I have val. If I remove val, it means I will have to redeclare this here and assign to it. Val means it's not changeable, right? So it is assigned and this is it. This is also val, this is also val. It means this class is immutable. Immutable means you create an object and this is it. It's not changeable. And this is typical for Android. When you generate objects that come somewhere from data layer or some business logic layer, it goes to GUI and this is it. It's not changeable. This enforces unidirectional data flows and single source of truth. So who owns the data, in this case somewhere data layer that is generating it, can change it. Otherwise, we get immutable objects that potentially can be duplicated. Okay. So this is enforcement of single source of truth and to avoid corrupted data. So how we can corrupt data by accident? Because Android is parallel code. And you will see. So one way to avoid corruption is not to change objects, just do copies. No, corruption means, in this case, not corrupting variable, but making inconsistent data. What do I mean inconsistent? When total does not match values in the list. Okay. In order to avoid this kind of updating conflicts, the easiest way just to copy object and make sure that it stays consistent when you copy entire object. This way, we will never get into a situation that one process is still updated. One process updated, say, values. Total is not updated yet, but you already read it elsewhere, so total is not matching the list. Just because Android tasks in your program are competitive, say, parallel, could be parallel. So one way to avoid inconsistent data is to create immutable objects like that. So what do I have here? A total is initialized from calculating sum of this list. So I got it here. Number of dice, it is just length of this list. Okay. So I created into string is converting it. This is not data class. If it were data class, I don't really need to string because it will make sensible to string inside. So this is to carry data, and data class has keyword explicit keyword data. So what is the role of service? It is not service mentioned before. So sometimes you can see the same word for different reasons. And in this case, service means just some functionality of the app, some business functionality. Okay. So it is creating a role data object by calling get role data for the number of dice. So if number of dice more than 0, it is doing it. Otherwise, it's throwing exception like before. You saw throw illegal argument exception, illegal value for that. Otherwise, it is creating list using build list function. And as you see, build list function is taking two parameters in this case. First one, it is capacity to pre-allocate storage inside. And this is a lambda function that is creating the list. And we call repeat for number of dice. It is a regular repeat loop. And in this loop, we call add function defined in build list to join, to add items to the list. Okay. So this will create a list of objects. Under the hood, list is implemented as an array. And this will, capacity number of dice will create array ahead of the time. So it doesn't have to copy this to bigger array each time when you add something. So this is optimization for the implementation as an array. And return raw data, and constructor of raw data receiving list and calculates total and calculates assigns number of dice. Okay. So this is the business logic of this app. Okay. Now, somehow I need to make this service linked to GUI, because GUI is kind of related to it, right? And imagine that this data is coming from web. Potentially it could. If like two people play dice through web. Right? So there are two complexities associated with this case. If it is somewhere on web, you need to create a connection to web, so you're creating objects. So it is more complicated than that. Second complexity, that there is a delay. You ask for the data and you wait for it. And you shouldn't freeze GUI while you're waiting for the data. So it is more complicated due to two issues. One, it is creating objects and connecting them to your service. And second, waiting for delay. And actually, third, task when you ask for the data and wait should not be destroyed when screen is rotated. So actually, there are four issues associated with it if it were like a real-life situation. So where did I put it? I created in UI just because okay. APP root screen, it is entire screen. We will look at this. I'm going through data right now. Okay. I created a role of view model. As you saw, recommendation from APP design is to inherit from view model, not Android view model. So it is current state of the recommendation. Why does it need to inherit from view model? Because it needs to have functionality like provided by the system, so these objects are created automatically. What if this view model needs to have a dependency, for example, on database or web dependency? So it calls a function to connect to web or connect to database. This would be kind of an issue because you need to provide some links to that stuff. And this constructor of this part, this is base constructor, will be called when object is created. So the issue is creating connection to objects outside. In particular situation, it's not a problem because you just call constructor without parameters of role as service. And you can call get raw data from it. But it would be an issue if you have a database objects that needs to be linked to role as service, or objects to access web that needs to be linked to role as service. Why? Because you cannot easily provide parameters. Because this is created automatically. Okay. So in real life scenario, it's some more complicated, but idea is somewhat similar. You have an object created by the system. How is it handled in real life situation? In real life situation, in more complicated case, we have parameters. And system is still creating this automatically, but it is using factory that if you don't use dependency injection system, you have to write class for a factory. And that factory object is creating view model object. So system is calling factory object that you created, and that factory object has those parameters, so you can do constructor call in it. Okay, so if we don't use dependency injection system, we do it manual dependency injection, we will need to create a factory with a method that is returning view model. Why? Because first time system needs to create it. Second time it needs to reuse it because it preserves the data. If it recreates the object, you will lose the data. Okay? So this is the meaning of the factory. It's an object to create other objects. And in this case, you tell the system, use this factory to create view model. If view model has dependencies, you have to create view model factory. In that, we'll call the constructor. And system will call view model factory method to create this view model when it is necessary. And when it is necessary, create it when it doesn't exist and do not recreate it. So you preserve the data inside of it. In system, in simplest case scenario like this one, you don't need factory. You also don't need factory if you use hill dependency injection, because factory will be generated automatically. This is why it's somewhat simpler. Use hill dependency injection system, because we don't need to create factory objects. Okay. So what is this? Mutable state flow. Remember recommendations, what you saw in architecture guide that says use state flow and mutable state flow, blah, 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 right? Mutable state flow and state flow. It is not state. What you saw mutable state in GUI, it is not mutable state flow, and it's not state flow. They have state word in it because it's to store state. But mutable state flow does not trigger update of the screen. It's not designed for it. It's not GUI specific. Okay. So although it has a state on it, it's not able to update, to trigger update of the screen. As you see, it is not just state flow. It's not just state. It's state flow. So what is flow? Flow is an object to do data transformation. One of the functions data transformation. Others is to get data reactive way. Data reactive way. So technically, state flow state flow has two functionalities. State it is to store data, and flow to get data and transform data. Okay. So state flow has two pieces in it: flow and state. As there is a flow, that which is not state flow, it cannot store data. It can notify about data coming if you subscribe for it. So it is, for efficiency, flow is cold. And cold means it's not doing anything unless you ask for it. So unless you display the data, it will not make it for you, essentially. Flow. State flow is hot in terms of it will do data transformation for some time if it is used, and after this you specify timeout. So it is related to a guide that you saw, state flow and state. In this simple program, there's no usage of flow. Because data is just inserted directly. You see, UI state value, initial state. So when we call reset, UI state value, we insert the initial state here. And when we call on role, we call role service, get role data. This is role data. We assign it to UI state.value. All right? So we use just state in this case, and no flow features. Flow features will come handy if data is coming from data source. Why? Because flow is reactive. You can subscribe to update. When you subscribe to update, screen will be updated. In this case, you don't subscribe to update, you just assign it. So it is brute force use. Okay? So as you see, this is just brute force approach of using flow. So let's look at the top. Mutable, it means you can change state by assignment. Not mutable, just state flow. You cannot. Why? This is private, but this is public, referring to the same thing. What is the reason? The reason is to maintain data consistency, so it is enforced. View, like UI, does not own the data. It is only displaying it, single source of truth. In this case, who owns the data? State, right? So this is who is owning data. No, sorry, this is owner data, right? And only this owner of the data, single source of truth, is able to change it, right? So it is able to change it by calling role function, and it is using UI state, which is private. We would not expose it outside of the class. Right? So this is how to change it, and this is how to change it. Both are methods of view model. Right? This is single source of truth, owner of the data. That can change it. What is exposed outside? Immutable. Because state flow does not have public dot value option to assign to it. Because it's not mutable. It is referring to the same data but different class. Why can I do that? Because mutable state flow is inheriting from state flow. You can assign child class reference to parent class reference. So it is typecast, right? So if you have a class vehicle and you have car inherited from vehicle, when you create object car and declare variable vehicle, you can assign object to that variable. You can assign object car to variable vehicle. This is what happens here. State flow is a parent class to mutable state flow. This is why mutable state flow object can be assigned to state flow. Because this is a parent, this is a child. When we create mutable state flow object, it is absolute requirement to initialize it. This is to avoid crashes. There's no constructor without initialization. Okay. So we need some data to initialize it, like init state. And I did it in companion object just to create constructor. And it is UI state not roll it. So we need to know what it is, right? Because it's not discussed yet. So we didn't discuss what is roll it and not roll it yet, right? So let's look at this business logic. Data. Where did I say it? Okay, roll a UI state, this one. Is this an interface? I remember that previously we discussed it, that interfaces and classes could be sealed. Sealed means we can inherit from them, but only within the same file or even within the same interface or function, interface or class. You know that in Kotlin, by default, you cannot inherit from a class unless class is declared either open, abstract, or sealed. Right? From interface, you can inherit by default, but if it is declared sealed, similar to class, you can inherit only within the same file or even within the same interface. So this is used as scope. So when I refer to, say, roll it, I will have to use prefix roll UI state dot, because it will be used as a scope. So what do I have? What do I have declared within this interface? A number of dice, right? Value. Can we have values inside of interface? Yeah. Why? Because a value declared inside of interface, it is not number. It is setter and getter. Where this number is stored? In child, in implementation. In classes that inherit from interface. So this is the reason why we can have it here, because it's a property, it's not a variable number. Okay? Where this is stored, this one, it is stored here and in here. That implement given interface. So I have data class, roll it. Data classes are designed as just to store data, right? And they come with a lot of useful features, for example, string, hash functions, and what we really love is copy function. We will use that copy function a lot. Maybe not in this program, but later. Okay? So what do I have here? You see, I'm overriding interface, interface property, so it is override val, int, and I provided getter for number of days. So as you see, in this case, get, this is calculated each time, which is roll data dot number of days. Okay. So it's an example when getter is returning calculated value. All right? So it's also how to do it. So UI state is either roll it or not roll it. In both cases, it carries number of dice inherited from it, because not roll it 3 dice is still valid, right? You have 3 dice, but you didn't roll. And roll it, you have also not just number of dice, you also have raw data that contains number of dice, which is the same thing because it is calculated one, right? And contains number of dice, result of the roll, and what else? Total, and time when it was, date and time when it was rolled. So this is what I added. So roll it class, data class contains roll data essentially and time stamp when it was rolled. Okay. So UI state can be in 2 variants in this program. Roll it and not roll it. Okay, it's not my craziness, I promise. I saw this in Google examples a lot. Right? When they define sealed interface and implementation inside and use it, these two as a switch of the state. I promise it's not designed, it's just to annoy you. I'm trying to explain that happens a lot in Google examples. Okay. Okay. So it's also example of sealed interface. Kotlin feature. In this file, there is no Android. It's pure Kotlin. Okay. So in order to create this one, we have to call constructor. This is what happens in view model. Where do I have it? Role of view model. Okay. So when we call on role, you see UI state value is assigned by calling this constructor. Role data, where does it come? From this service, right? Role data. We call service to get role data. So it is given to as a parameter of the constructor and date, which is timestamp. If you will call date constructor, it is current timestamp. So this is how state of rolled state is created. Not rolled state is this one, initial. Not roll it, and we will just provide number of dice to the that constructor. It takes only one parameter. And I got not roll state. Okay. Questions about this? So it's already using state flow. We can store state, not state flow. Okay. I decided to pick this one because I already referred to design guide and say use state flow, not state in view model. We can use state. We can store state. One of the examples is using state. You will see. It's not recommended, but that example came from Google, so I'm not guilty. Okay. Questions? And again, there's no flow functionality used at this moment. So state flow has a box to store state and some pipe attached to it, and we're not using that pipe. I call pipe flow, but technically it's not really a pipe. It's another object. Okay? But idea is to have something updated reactively when database is changing, for example. Okay. Questions about this? Okay. Now, we need to convert it into something that will trigger screen. Okay. So first, let's look at root app screen. This is entire screen. This is not mutable state. This is state. A mutable state is different from state you can change content of it. And there is also parent and child relations between mutable state and state. Yes? So what will come is mutable state. No. When you say collect a state, on state flow, it will create state. So it's not mutable. This was state, public is state flow, right? So why do I need this transformation? Collect as state. This is function of a state flow to create an object that can trigger update of the screen. So this is the key point. State can trigger update of the screen. State flow cannot. So I need to do conversion from the object that cannot update, trigger update, to the one that can. So this is the primary purpose of it. Collect a state is doing data transformation of one object to another one. Questions? So when we change stuff there, this object is assigned and it will trigger update of the screen. So this is a state the same way as you saw at the previous lesson, mutable state of something. A mutable state, that means you cannot change it by assigning to this variable. It's a parent class of state. As you see, I'm not using by here. It is more explicit without. Like I started previous lesson, like I started example at the previous lesson without by. Sometimes by is not possible. And this is why we need to do both. Due to logic of the program, it's impossible to use by. In many cases you can, but not always. Right? So what happens here? This is state, and you know that state has a value in it. We previously assigned it to it, right? When it was mutable. And now we can, and this is a roller state. What's that? How to get rid of this stupid thing? Like I'll just scroll it. So this is value UI state. What does it contain? UI state is roll it or not roll it. It could be two options. So at some moment, at some point, we need to do switch between roll it and not roll it. Okay. So what's this one? It is scroll behavior to link scrolling of the screen to the frame. Okay. Sorry, kind of close, but not exact. To bar defaults enter always scroll bar behavior. What it is? It's behavior of toolbar on the top. So it's not a link, sorry. It is behavior of toolbar on the top is specified. It is behavior how we want top bar act when we scroll window below. Because it can fold or it cannot, really depending on our settings. Okay. So this is one of those. Okay. We will see what it is. So it's a behavior of scroll bar. What is this part? This part as you see, I'm using by remember savable mutable state of Boolean. As you see, this is not stored in view model. It is stored locally. Right? Like we learned at the previous lesson, we can create some state variable directly in compose function that will trigger update of the screen. And so it is using this, and it is Boolean, true or false. What does by means? It's setter and getter delegation because this variable is Boolean. This is creating state, mutable state object that contains Boolean. So by is delegating setter and getter from this Boolean variable to state object. So when we assign to this variable, it will call setter of that state object and trigger updates of the screen. Okay. When we use this value, it will call getter of that object. What does it about? About showing dialog, right? Logically, by variable name. And remember savable. At the previous lesson, we learned about remember and remember savable. There is a difference. Remember creates value, in this case object, right? Or object that will be remembered between function calls. Because those composable functions are called repeatedly by the system when it is refreshing the screen. And you don't want to lose that value when screen is refreshed for any reason. So it has to be remember. And at the previous lesson, we learned about remember savable. Remember savable preserves that object when we rotate the screen. Okay? So this is a flag if we need to show the dialog. Right? And I don't want flag to disappear. I don't want dialog disappear when we rotate the screen. So I'm preserving this flag as remember savable. Okay. So it is pop-up dialog about. And this is a flag for it. Yes? So let's scroll to the bottom. See, show dialog. And I'm calling constructor to create this dialog, and it will pop up. No, sorry, it's not constructor. It is composable function that will create the dialog. Okay. Again, that's game about. It is composable function. Somewhere below, here it is, that creating a dialog, alert dialog, by calling constructor. This one. And this is behavior of the dialog, what to show, what to do on clicks of those buttons. So how to show dialog? You create, so what do you learn here? How to show dialog. So you create a flag variable, show.show, and you update it to true when you click something. And since it's state variable, system will call this function again, this one, reach this point, no, not reach, again, go down, reach this point, and now it is true. And it will call compose function to show this dialog. Okay. So when this variable is updated, it is updated from toolbar, and it is updated from the dialog itself when we close it. So let's see what is inside of the dialog. Okay. What is this? This is parameter of the function, right? This is type of the parameter. In the beginning of the course, we learned that lambda function can have type, right? So it's a type of type of this parameter is lambda function that is not returning anything. Unit is the return type, and it's not taking any parameter. So when we call this one, we provide lambda function to be called on dismiss. Okay? And where this on dismiss request is here. When is it? Where is it? Sorry. On dismiss request, on dismiss request. So you pass it to parameter of alert dialog. So when we press on the button in alert dialog or press outside, it will push it out. Will not have it on the screen. Okay. So this is how to get rid of it, right? On dismiss request. So when we call dice game about, where it is? Okay. So let's go there. So what happens? What happens in this lambda function that we pass? We just update state variable, which will trigger screen. It will reach this point and do not display this dialog. Okay. All right? So this is how you can put it inside of your model. Could be. But if it's some simple flag, like for pop-up dialog, you can do it in GUI. I have another example where the same thing is also in vModel. But this shows both. Okay? So this is the idea of how to show and hide dialog. This is also updated inside of toolbar, where it is. Scaffold. Okay? This is creating flag variable, right? So we're here, creating flag variable. I discussed. What is scaffold? Scaffold, how to get this? I have no idea how to. So annoying. Oh, disappeared call. So, scaffold. At the previous lesson, we learned what is scaffold. It's compose function that connects pieces of the screen, like top bar, bottom bar, some navigation, and roll floating action button. This example has both, or all of them. Top bar, it's a parameter scaffold, and assignment, it's lambda function to be called. So I call roll top bar, roller top bar, compose functions that I created myself in the code to define top bar. And what do I pass? Lambda function. That should be called when we press help button. Right? So what does it do? Show a dialog true. Looks logical, right? So I created lambda function. I created compose function that takes parameter lambda function to be called when we press help button. And this lambda function is flipping the state variable that triggers update of the screen. So this function is called again, top to bottom, reach if. Now if is true, and it will show dialog, create dialog on the screen. Right? So this is the idea of storing state outside of compose function. Okay. Why? Because sometimes we need to update state outside of the function. Right? So this function, this updating state, store it outside. Why? Because it needs to be used outside. So this idea is called hoisting, storing data outside of compose function that has some functionality with it, like update. It is used a lot in user inputs. Because if you have user inputs, typically state is outside of. If you define compose function for user input, state is typically outside of it. Why? Because you need to do it outside of box where you entered, essentially. You need to use it outside of the box when you entered. For example, you have several inputs and you need to do calculation. Obviously, values from these inputs needs to be in one place in order to do the calculation, right? So you cannot store them separately inside of compose functions that have inputs. Okay? So this is top bar. And this is just brute force top bar, nothing fancy. Okay. Center line at top bar. This receives scroll bar behavior. Remember, it needs to be linked to scaffold. And this is what to do on the help button. We have icon button that calls on click this help button. On help button click lambda function. So what happens? Let's show. It is starting. Okay. It's still starting. It is this button in top bar. So this icon button, it is this one. Okay. And when I click on it, it is calling this lambda function, pass it as a parameter to roll top bar. And as you saw, this lambda function is updating flag, and updating that flag triggers update of the screen. This is why I got this. Okay. When update of the screen happens, it calls function again with different flag value. It will reach the point where it says display the dialog. Because if in that case will be true. Okay. If I click OK, it will call that on dismiss. That will update flag. Updating of the flag will trigger update of the screen. It will call lambda function top, that's what you saw on the screen, top to the bottom, it will reach the point where if is false. And so during that update, it will not display the dialog. So it is this, and I believe I click outside, it will do the same. Okay? It's the functionality of that dialog, alert dialog. Either OK, we'll kind of close it, or click outside, we'll call this dismiss. Okay, questions? So this is about the button and toolbar. As you see, as most of GUI code is not short. It's not Android specific that GUI is long. And it is just nature of coding GUI in any program environment. Okay. And the best way to learn it is just to go through examples from Google, from internet, from what I post on Slate. Because going just from documentation, it's such a chore to figure out how to connect pieces together. Okay? So the same for me. When I was learning it, I was learning this from examples. Look up documentation if it's not clear what it is doing. So it is a little time-consuming to get comfortable with it. And of course, I don't remember it. I copy-paste. Okay. I remember it only when I look through, I remember. When I close this file, I don't. I try to remember principles, how it was working, general ideas. But how would you remember exact parameters of each functions? Okay. So the goal is to understand basic principles. So you can understand written code, you can create similar code, understand documentation. Trying to memorize it, I don't think even anybody can recover this directly from memory. Okay. So when you start typing, it helps a lot. It will give you parameters of the function, you type it, if you do not clear lookup, copy paste things, lookup alternative. When you have something created, you can play with it to make it better. So it is always iterative process, and unfortunately, it's not short. Okay. And it's not just because it's such a nasty thing. It's not. It is just nature of GUI. Most of the GUI code is not short. Okay. So what do we have now? We are here, and we figured out dialog logic. Remember that scrolling option. I cannot. You see, this is behavior what is specified. There is also option, do not fold it when you scroll. And this is foldable option. Look up. And it's not difficult to look up. You can just experiment. You put dot, it will give you other options. Choose other option, see how it behaves. Okay. So this is definitely input, right? So a result of this input should be visible outside of it. So I need to have some lambda function updating something else outside. So this input is wrapped in composable function that is receiving lambda function as a parameter that will update the state. And it needs to display the state as well. So this input has at least two parameters. One is the state to display, and lambda function to update state which is displayed outside. Okay. In Android, this is composable, Android composable, all inputs works like this. If it is your own function, you wrap it as input, or original one like ready button or checkbox. They receive parameter to display, and they receive lambda function to update state outside. So in Android, state is not stored inside of inputs. It's always outside. This part is more complicated because it's complicated input. Radio buttons and checkbox are a lot simpler. And just text box, when you type it, it's also simpler. Although it has tons of parameters, you really have to copy paste it. Because those too many options, essentially, for text inputs. So what else we have? This is top bar. So let's go here in app root screen. This is top bar, floating action button. It is this part. Okay. How to get rid of this thing? Oh, no. It is the button that is floating here. Okay, how to... Okay. No.
You can try pressing on the tick on the top, right?
Yeah, let's try.
The green tick. The green
This one?
No,
Still has this is on top.
I was going to say, press the tick on the top, right? Like the green check mark?
No.
Or you can make the screen bigger. I think it should work out.
Oh, small action. Okay, this one, yeah. So this is executing role. Right? So this also needs to receive lambda function to update something. Right? So floating action button. This is a system function, floating action button, on click and on roll. Remember that on roll, it's a method of viewModel. On roll, we created inside of viewModel, right? But what is expected is lambda function. This part is conversion. Double dot, you saw it on slides when we learned Kotlin. It's conversion from regular function or from method to lambda function. So this is just to the match type. Okay. So it's calling on roll, it's not passing parameters because just that function doesn't have parameters. When you do double column for type conversion, number of parameters of the lambda function should match number of parameters of the function that you call. Otherwise, it will not compile. So what happened here? Icon, we picked icon. This is system icon provided. There are two kinds of icons. One that comes with composables library, and additional that you add in Android Studio or just import as a file. This program has two kinds to show the difference. This is coming with composable library, so you don't need to do anything except knowing name of it. What you type and you select what is prompted. There are additional icons that you added to drawables, like this one, using Android Studio. So Android Studio generated this one. Another option is to add stuff, how we added dice here. So we can add by importing resource. So how did they add this icon? Since we're looking at it, you click on new resource, vector asset. And now click on this and try to search. Oops. Didn't come. Okay, let's click cancel and try again. Let's see, figure out what's this. Clip art. This is local file to import. So clip art. Okay. How did I got it? Just 1 second. Fill it round sharp tone. I wonder why it doesn't show up in help. Maybe it's not called help. No, it was called help. No. In previous Android Studio, it wasn't actually selection. It was just type 1.
You can try the other drop down. Maybe it has more options.
All, it's all. How can it be?
No, but you can delete help and you can search from there.
Oh. I'm pretty sure that I typed help because it did come up as help. You see, it has word help outline. Perhaps they renamed it now. Who knows? But this is how I edit. Vector asset, clip art, outline it. Maybe they removed it for some reason, I don't know. Okay, but I will figure it out. So this was the logic how I added this question mark. Perhaps it is previous version of Android Studio, for some reason they don't have this question mark anymore, who knows. And when you edit next, you will get it. I will figure out why we don't have it, which is interesting. Totally unexpected. But this was idea. How I got that part. And it goes to the source, so you can refer to it. So this was in when I created toolbar, so it is you use it inside of the toolbar. So that was floating action button. String resource, it is resource what is use it to describe it. There is also a description option for screen readers. It is in the resource for purpose of translation, because screen readers also should be language specific. It is the reason why it's not on the screen, but screen reader should use the language of user preference. And last one, it is content window. Right? So what do we have? We have column of the stuff on the screen. Then we have number of dice input. And what is this? On change number of dice inside of view model. Right? So it's a function that will change state of number of dice inside of view model. And it is conversion from lambda function to function inside of view model. Right? In both cases, it requires one parameter. This is why there is type match. Okay. Number of dice input provides one parameter, it is what is selected, and it goes to function that receives one parameter. Here it is. Below stuff is changing depending on, and this is when. Remember that when it is like switching other languages, and we can have is, it is type check, inside of when. Okay. When roll it, I display one composable function called roll it body. Okay. It's one layout, and when it's not roll it, it's another layout. So this is how this switch happens. I'm not sure where it is. No. Okay, here it is. This is not roll it. It is below. Okay, okay, let me show. Number of dice input, it is this one. Then I have when, is roll it, is not roll it. This is not roll it. I click roll, and now UI state triggered changing of UI state triggered update of the screen, and now it shows roll it body, this stuff. This stuff. And what is below is two buttons that always on the screen. Okay. This part is switching depending on the state, and two buttons below always on the screen. Other things are just a little tedious details. Okay. So this is basic idea what is going on. Update of the state inside of your model. That state cannot trigger update of the screen, so we need to convert state flow to state, right, by calling that conversion function. We do have composable functions inside of the composable functions to compose the screen. Events are propagated using lambda function call. For example, we click on this. It will create lambda function call that calls another lambda function call. Eventually, it reaches view model. No, this is not reaches view model. It is reaching flag, right? Show or not to show dialog. But when we do this, it will reach view model. You saw that it is calling on number of dice change. inside of view model that is changing state. Okay. Why? And it is the reason why not roll it also storing number of days. Because this should work even when it's not rolled. Why? Because you need to store the selection somewhere. Okay? This is why it needs to work even when it's not rolled. Okay. So it is rational to store number of dice even when it's not rolled. So does it look large? I cannot do much about it. Of course, this could be made somewhat shorter, but imagine that you have a program with multiple inputs, like maintaining data of something, right? And this is not really lots of data in it. So just get ready to deal with lots of code, okay? If we look carefully, we may just cut corners a little bit, but it is this code is written such way it's easier to understand. I tried to use reasonable names and separate files, and it has only one page, as you see, right? So at the next lesson, we will continue with, this is probably mostly, what we didn't do, we didn't create view model manually. Right? Creating view model does require library. So which part requires library? So we have 5 minutes, right? So let's talk about that. At the top you saw this function call, right? This function call requires view model composable library. This is not included by default. You need to add it to your project. Okay? This one. This is fancy function that you call to get view model. It will ask system, give me view model if it existing, and if it doesn't exist, create one. If you don't use dependency injection, you need to provide parameter which is factory object. This is what I was talking about. Because you ask system to create this view model, right? Or do not create it, so it needs to have a choice, but it needs to know how. If view model takes parameters, constructor takes parameters. So if your view model takes parameters, and you don't use dependency injection system, you have to create factory object and give it to your function as parameter. So this is where factory plays in. Okay. So technically, this is creating view model when it doesn't exist. We can have as many view models as we like, provided they have different type. Okay. And typically they do, because you have different screens, and you don't have exactly the same screens, right? So you call view model with the screen, like you have a list, like of emails and emails. You can email and list of email. So email. So you can say email list view model, it will be one type, and display email or edit email view model, something like that. It will be another type. So how does it know? It is reading type here. Okay. So it is picking type from here and is calling constructor of this type. Okay. So view model, we can have view model per type. If we declare view model this way, it will exist through while activity exists. It is not optimal because what is optimal is to have it per page. If we have more than one page, why would we carry data of another page while we display this page? Right? Currently, there is no way to deal with it without Hill dependency injection system. So if we want to have view models per page, we have to use Hill dependency injection system. It is available only there. Otherwise, when you create view models per page, they stay global per activity. You just call it them differently, but they are not really per page. They're all global per activity. Okay? So in order to have view models per page, we have to use hill dependency injection systems. That would be indeed optimization. When you go from one page to another one, it will discard data from the previous page because you are not displaying it. We don't care. Okay. And it's also optimization for tasks, which is important. For example, you ask for some data on the current page, but you didn't receive it, you browse to another page. If it is global, it will still work on receiving this data. But if it is per page, that task will be killed, which is a sensible way to do. Because you don't display this page, why would you ask for the data? Continue waiting and asking for the data, especially if it is local one. Right? So using Hilt, especially for this purpose, is a good idea. We will learn how to do it. And also, when we use Hilt, we don't need to create factories, which is also a plus. They generate it. Okay, questions? So time to finish. 10:50. We need to finish at 10:50 because we should end at 11, right? Starting at 9? No, we started at 8, starting at 8, so we end at 11. So I will stop recording, I will post it.